Dear viewers, I extend a hearty welcome to all of you in this new session on the discussion on the topic of the salt analysis. Till now, we have discussed general introduction of the salt analysis. Then we started preliminary tests of the acid radicals. In that, we discussed the preliminary test dilute H₂SO₄, and the radicals which we identified with the help of dilute H₂SO₄ test, we studied their conformation also, their conformity tests and the theory behind that. After dilute H₂SO₄ test as a preliminary test, next we discussed KMnO4 test as another preliminary test. Now in today's discussion, in today's lecture, we'll be discussing the concentrated H₂SO₄ test as a preliminary test for the detection or identification of certain acid radicals. The acid radicals to be identified with this test are as follows. It is chloride, bromide, iodide, nitrate, acetate, and oxalate. I am eliminating the radicals like fluoride, tartrate, arsenite, arsenate, etc. from this discussion, as I discussed that this is a preliminary discussion for the beginners. Now, let's start the concentrated H₂SO₄ test. Procedure for this. You see, when a mixture is given to us, it may contain radicals to be detected with dilute H₂SO₄ also. So in that case, what we do is that we add dilute H₂SO₄ to the salt mixture in a test tube and observe if some reaction takes place or not. If some reaction takes place, then we warm that reaction mixture almost to the boiling level so as to decompose these radicals which are detected or identified with dilute H₂SO₄ test. And if there is no action, it means there is no radical which is to be detected with dilute H₂SO₄. Then what we do is, now we add about half or 1 milliliter of concentrated H₂SO₄ to it and heat the reaction mixture. Kindly note that when we are to perform dilute H₂SO₄ test, it is generally done in cold. Or sometimes in case of sulfides or thiosulfates, etc., we may warm a little, but concentrated H₂SO₄ test is always done when we heat the reaction mixture. So as I said, that about 1 gram of the salt mixture and a milliliter of concentrated H₂SO₄, and we strongly heat it, and we observe some gas coming out. If some radical to be detected with concentrated H₂SO₄ is present in the reaction mixture, then of course some gas will be emitted, and by observing the properties of that gas and the tests involved, we can identify the radical. Now we do it one by one. First of all, let's say chloride radical may be present. So how to identify it? We perform the test and we observe the gas. Colorless vapors will be evolved, which will be having pungent smell. And if we bring an ammonium hydroxide rod, a rod dipped in ammonia or ammonium hydroxide solution on the mouth of the test tube, then we get dense white fumes. So how does it happen? Suppose we have got sodium chloride as chloride. We heat it with concentrated H₂SO₄. We get the formation of sodium bisulfate plus HCl vapors are evolved. Now these HCl vapors, when come in contact with ammonium hydroxide, then they form ammonium chloride plus of course water, and this is white in color. You see, there is a difference between colorless vapors and white colored vapors. The HCl vapors will be colorless, but since ammonium chloride is a white solid, so when HCl comes in contact with the ammonium hydroxide, then you get white fumes. That indicates the presence of chloride. Now, after this, we come over to the next radical. That is bromide. Now, what indications do we get in case of bromide? In case of concentrated H₂SO₄ test, we get reddish brown vapors, of course not very intense, but reddish brown vapors, and which when brought in contact with moist starch paper, that paper turns yellow. Now, how does it happen? Suppose we have bromide as sodium bromide. It comes in contact with concentrated H₂SO₄ on strong heating. It decomposes to give you plus HBr. Now, HBr itself is not colored. It will be colorless. So what happens? That this HBr is now oxidized with sulfuric acid. How? H₂SO₄ gives us water plus sulfur dioxide plus nascent oxygen. This nascent oxygen now reacts with HBr, oxidizes it, and bromine gas is liberated. Now, this bromine gas is reddish brown. And when this reddish brown gas comes in contact with moist starch paper, then starch bromine complex is formed, which is of yellow color. Now, after this, similarly, we come over to iodide I negative. Suppose we have got sodium iodide with us. On heating with H₂SO₄, this gives us NHSO4 plus we'll get HI. HI itself is not, colored. Then, and in this case, I just forgot to tell you that in this case, when we treat an iodide with concentrated H₂SO₄, we get violet colored vapors. And from where these violet colored vapors come? In the first equation, we see that HI is formed. HI, as I told you, is not violet colored. Then similarly, as it happened in case of HBr, in this case also, HI is oxidized with concentrated H₂SO₄ to give us iodine. How? I write it once again. H₂SO₄ gives us water plus sulfur dioxide plus nascent oxygen, and this nascent oxygen combines with 2 HI to give you water and iodine vapors, and these iodine vapors are of violet color. And when they come in contact with moist starch, then they form starch iodide complex, which is bluish in color. If quantity of iodine is more, then it becomes bluish blackish. So our observation is that if we get violet colored vapors in case of concentrated H₂SO₄ test, and those violet vapors turn moist starch paper blue or blackish blue, then it is iodide. So these were 3 halogens, halide ions. After this, we come over to nitrate. Nitrate and nitrite, they are quite similar. However, nitrite is decomposed with dilute H₂SO₄, whereas nitrate is decomposed by concentrated H₂SO₄. So suppose we have got, say, some nitrate, let's say sodium nitrate. When it combines with concentrated H₂SO₄ on heating, we get the formation of this. Okay, what to write? 2HM3. Okay. Then here also we'll have to have 2H₂SO₄. Now, you see, in this case, generally, what we tell or what is written in the books is that in case of strong heating with the concentrated H₂SO₄, you get reddish brown gas, but this reddish brown gas will be slight reddish brown gas. Not enough reddish brown gas. It may confuse you that is it from HBr or bromine or it is NO2. The test for that is that if you add carbon to it, we generally tell that add a paper pellet. What is paper pellet? A piece of paper just rolled into a ball, small ball, and it is thrown in the test tube. The paper of this paper pellet is what? Carbon. So that carbon, accelerates or promotes the dissociation of HNO3. You see, this is HNO3. Upon heating, it will give us water plus 2 NO2 plus 1 nascent oxygen. And if some oxidizable material is present, this reaction will be favored, or this reaction will be fastened, or this reaction will be, increased its rate. And now this nascent oxygen combines with carbon. This is paper pellet. Of course, if you want to balance it, then you can write like this, that it is K plus 2 nascent oxygens. You can have this 4 HNO3 will give you 2 water and 4 NO2 and 2 nascent oxygens. So just this nascent oxygen combined with this to give you carbon dioxide. You can do this with the paper pellet, or you can do this even with the copper turnings. In that case also the same will be there. We'll be discussing this when we discuss the conformity tests of nitrate. There we'll be discussing copper turning test. So if on heating a salt mixture, the H₂SO₄, we get the evolution of light brown gas, then and we add a paper pellet into that, and with that this process is made faster and more NO2 gas is evolved, and which gives us a reddish brown coloration. So this reddish brown gas will indicate the presence of nitrate. Now after nitrate, we come over next to acetate. In this case, we take the salt mixture, heat it with concentrated H₂SO₄, and check the properties or characteristics of the coming out gas, and we get the smell like that of vinegar. So how? Let us say we have got sodium acetate. We add H₂SO₄ to it. We get the formation of sodium sulfate plus CH3COOH. This is acetic acid, and it has got smell like that of vinegar. What vinegar is, all of you know. In common language or local language, it is known as sirka. It has got a sour sort of smell. You might have observed whenever you go somewhere in the restaurant, then they provide you onions soaked in vinegar. And that vinegar-like smell, if you don't know, then perhaps you might have gone to the restaurant, you might have experienced that smell. So it is smell like that of vinegar, and it is due to acetic acid vapors, and acetic acid vapors were evolved from an acetate. And after acetate, we'll be discussing oxalate. Oxalate ion. It is like this, or generally it is written as C2O4 2 negative. Now in this case, the salt mixture is heated with concentrated H₂SO₄, and we observe the characteristics of emitted gases. If a colorless gas with no smell, colorless, odorless gas is evolved, then it is due to oxalate. What this colorless, odorless gas is? This colorless, odorless gas is carbon dioxide. You know, we have studied earlier also that carbon dioxide gas is evolved by the decomposition of carbonates and bicarbonates, but those carbonates and bicarbonates are decomposed with dilute H₂SO₄ test. So if there is no evolution of carbon dioxide with dilute H₂SO₄, it means carbonate and bicarbonate is not there. However, if there is an evolution of carbon dioxide with concentrated H₂SO₄, then it may be due to the presence of oxalate. We'll be writing the equation now. You see, we get the evolution of a mixture, that is carbon monoxide and carbon dioxide. And sometimes we make a provision to check the presence of both these gases also. First of all, I write the equation, then we'll discuss this. Suppose we have got sodium oxalate. We add H₂SO₄ to it, heat it, we get the formation of sodium sulfate plus H₂CO₂, this is oxalic acid. Now again, oxalic acid is oxidizable. So in that case, sulfuric acid will play its role as an oxidizing agent. So H₂SO₄, this will give us water plus sulfur dioxide plus nascent oxygen, and this H₂CO₂ will oxidize it, and it will give you water plus carbon dioxide plus carbon monoxide. Now we get a mixture of carbon dioxide and carbon monoxide, and incidentally both these gases are colorless and odorless. So sometimes we perform an experiment to prove the presence of both these gases. What this experiment is? We pass this gas mixture through lime water, and in that case the carbon dioxide is retained by the lime water, and this is usually done, you know, suppose this is test tube and we have got a sort of apparatus, you may call, you may have it like this or you may have it like this. Like this. Here we fill lime water. This is placed in the mouth of this test tube. There are reactions taking place, and from here carbon monoxide and carbon dioxide gases are coming out, and these gases are taken here. Then this carbon dioxide is retained by lime water. We have discussed this test earlier also, that lime water is calcium hydroxide. That will pick up carbon dioxide to give you calcium carbonate, and the outgoing gas is carbon monoxide. Then what we do is that we ignite this gas, outcoming gas, and what we see that it burns with a blue flame. So that means that it is carbon monoxide which is burning by blue flame. So generally we don't perform this test, but actually if we want to perform, then this can be the test. So in this way, I have not, as I told earlier, I have not touched upon fluorides, then tartrate, then arsenite, arsenates, etc. So up to this, for a beginner, The concentrated H₂SO₄ test covers the identification of chloride, bromide, iodide, nitrate, oxalate, and acetate. So I hope this account of various tests for the radicals to be detected with concentrated H₂SO₄ and the chemistry behind this, you might have understood this. Then in our next episode, whenever we meet, in the next lecture, I'll be discussing with you the confirmatory tests of these radicals. So kindly go through all this, and this is all, you see, everything is given in the book. The only thing is that when somebody is talking to you and you have an intention to understand, then you relate yourself with that. And I have used a word here, intention. You can tell 10 people to understand something, but only that person who has an intention to understand, he can understand. So, my friends, if you have an intention to understand, you might go through all this content and it will be definitely helpful to you. So, आज के एपिसोड में इतना ही. Thank you very much.